Hi everyone and welcome to Drive-Chris Capredoni, your source for automotive reviews, analysis, maintenance, and restorations. Please subscribe to our channel, watch the entire video, watch our other videos, and of course click on notifications to be first to learn about new videos. I'm Chris Capredoni, and in this how-to DIY video, I will explain and demonstrate the steps necessary to test and verify that a radiator fan is operating properly in a Buick Encore or a Chevrolet Cruze. During hot weather or when the air conditioner is engaged, it may become necessary for the fan to run while the engine is on or even when the engine's been switched off in order to assist in cooling the engine and the coolant. There are relays and a resistor that provide current to the electric fan, and their proper operation can be critical to signaling the fan to run and when to stop when necessary. Let's get over to the vehicle and examine and troubleshoot any potential issues. So today I wanted to walk you through how to potentially diagnose a problem with your radiator fan. It's an electric motor that runs off of a series of relays as well as a resistor that's built into the rad fan. But in order to start with a diagnosis of whether it's running properly, whether it's just running at high, not running at all, or running at low speed and not running at any other speed, the first step is to identify which relays are powering the system. So for GM, it's a 5 relay system, starting with over here in the engine bay. This is the engine bay. So starting over here on the driver's side, I've popped the lid, and the 3 relays that are important to powering the cooling system are these 3 over here. That's the low, that's the medium, and that's the high. So all 3 of those relays need to be properly operating to give the electric fan its full range of speeds. Now, it doesn't end there. I mean, I'm going to be testing those relays for you to help you diagnose the steps necessary. But over here, there is a smaller little fuse box that has other relays, smaller relays. And the 2 that are important are this one, low, and the high. These 2 power the electric fan as well. So they take current from these relays here. So if any of these 5 relays are not working properly, the electric fan will not work properly, and then you're going to start having overheating issues and cooling issues with your engine, especially on hot days or when you're using the air conditioner, or both. So, for example, on a low setting, this relay here would be powered, and it would be powering this relay here. On a high setting, this one here would be powering both of these, and then the medium, it's a combination of that. So that's why it's important that all these relays be working properly in order to have the cooling system, the cooling fan work properly. So what I'm going to do is I'm going to set up and start showing you the 3 tests on how to test each and every one of those relays to factor out whether it is a relay issue or whether we have to dig a little bit deeper. So the first test I'm going to do is testing for resistance. This is one of the main relays powering the system in the main fuse box. This is the low one. And what I'm trying to do is test for resistance, meaning I want to be able to see if I apply, if a current is applied, that the coil or resistor inside is properly operating. And the range that I want is between 50 and 120 ohms. So I have a multimeter here set to ohms, 200 ohms, because the range I want to get is between 50 and 120. Most resistors have a little diagram on them which explains what the mapping is for the particular relay. But what's important and key to note is that there's an 85 pin, which is negative, an 86 pin, which is positive, an 87, and a 30. What I want to do is I want to test the resistance between pin 85, the ground, and 86, the positive. if I can get a reading from the multimeter between 50 and 120, that tells me that this relay is good, and I can move on to all the others to test whether resistance is within the normal operating range. So what I'm going to do is just power up my multimeter, and I'm going to put the negative to the 85 and the positive to the 86. And the reading I'm getting is 73.5, which is within that range. So that's telling me that this resistor, this relay here, has the proper resistance that I require. So I need to move on to the others to test whether they are the same as well. The next relay test I want to do is I want to test whether the switch inside opens and closes when it's energized. So again, I'm going to be using the same pins, 85 negative and 86 positive. This time I'm not using a multimeter. I'm just using a simple 9-volt battery that's ample power for me to activate and energize the switch. If I hear and feel an audible click coming from inside the relay, I know that the switch is working properly. So I'm going to hook up my 85 to the negative. Now when I touch the positive to the 86, I should be able to immediately activate and energize the switch, and I should be able to hear an audible click. Now I don't know if you can hear it, but it's definitely strong and working properly. So this is past the second relay test. So the final relay test I want to do is I want to be able to test resistance while the relay is energized. So if we recall from test number 2, I was energizing it with a 9-volt battery. So it's still being energized. So the switch is open. I want to test the resistance between pins 30, which is the negative, and pin 87, which is the positive. So what I'm going to do is while it's being energized, I'm going to power it on. I have it set to 2000 ohms. And what I want to have is a resistance of 0 or as close to 0 as possible, meaning that there is no resistance inside the relay. So I'm getting 0.0001, which to me is as close as possible to 0, stating that this smaller relay here has proper resistance when it is energized. So if all 5 of your relays pass all 3 of those tests, they're all fine. You need to move to the next step, which is testing the resistor that's connected and attached to the radiator fan. Since all the relays are operating properly, the next step is to go to the radiator fan and take a look at the resistor which is built into the housing. Now you can see I've removed the one screw at the top and I've pulled it out just so you can see what it looks like. The green part there, that's the actual resistor that's powering the electrical fan. Now, if that resistor is damaged in any way, this one's in good shape, or is not properly operating, you can do the resistance test number 1 for the relay to see whether there's continuity at the pins and see if it's working properly. If not, replace it. Now, I've done some research and GM charges just as much to replace this one resistor as Rock Auto charges to replace the whole fan assembly, which also includes the resistor. So the wise money is to go to Rock Auto, buy a whole new unit, which includes the resistor, and just install a new fan. It's just a couple of screws and moving the reservoir out of the way so that you can have access to it. But that would be the best way forward. So to summarize, if you're having issues with the fan, it's not operating at all, operating only at high speed or at low speed, the engine temperature is going up and you can't diagnose anything else, it's most likely the resistor here that needs to be replaced so that you can get proper functioning from the radiator fan and make sure that you're keeping your engine cool on those hot days and especially when you're using the air conditioner. I hope this was a very informative DIY video on rad fans. They're a critical part, they're ignored, but they need to be maintained in order to make sure that your engine's running efficiently and safely. Thanks for watching this comprehensive DIY tutorial on radiator fan proper operation testing and problem diagnosis. The vehicle featured in this video is a Buick Encore with a 1.4-liter turbo 4-cylinder Ecotec gasoline engine. The Chevrolet Cruze also has the same 5-relay setup as well as other subcompact GM vehicles. All connected relays must be tested to ensure they are operating properly, as well as the radiator fan assembly's resistor. If you discover any electrical component is no longer working, replace it immediately. Please subscribe to our channel, Drive-Chris Capredoni, and watch our other informative videos as your source for vehicle reviews, analysis, maintenance, and restorations.